Welcome back. So we're going to move on to proportions, specifically doing a hypothesis test for a proportion. And we'll start out with our fireplace variable, where we noted that 26 out of the 39 houses had fireplaces, which is exactly 2/3. I'm curious to note whether that's different from 0.5 that we looked at from our study about, let's say, 5 years ago. And if it's changed, that might maybe there's an insurance issue going on, or a fire chimney cleaning service, all kinds of different things. So we're going to start out with a blank slate. But before I do that, I'm just going to jump over to the confidence interval for proportions, where we did the same thing here, and we'll note a link to that at the end. So we'll start out by making my column a little bit wider and maybe jumping my zoom up. And then, of course, let's just save this as version 12. I know it's a lot of versions, but it's good practice to document how your progression goes. And more than several times, I've had to refer back to previous versions of my work. So we'll start out with the hypothesis statements. And I'm going to underline those. So HO, we note that. Let's see if I can get that pi symbol up. There it is. And so pi equal to 0.5 versus H1. Insert another pi. Kind of makes you hungry sometimes. Where we actually insert the not equal sign here. Just one more thing. Every time we do a new model, try and like to add a few things. And then the values that we're going to use will be in column B. Let's just quickly write justify that. We'll underline it. And the value here is that 0.50 assumed population proportion. And then we'll go over the inputs needed. Underline that one too. First thing we need is the alpha level for a type 1 error, which is 0.05. Now, there's a good note that sometimes you'll see confusion between a proportion and a type 1, and both technically are probabilities, but try not to confuse them. And then we're looking for our positive responses, in this case, the number of houses with a fireplace, which is 26, and then our sample size n, which was 39, and then we get our calculated sample proportion, which would be equal to 26 divided by 39. And I'll provide that formula for you, even though it's an easy one. And the next thing we're going to do is our calculated standard error. Standard error in this case would be for the sample proportion. So here, it's equals parentheses, our sample proportion times more parentheses 1 minus our sample proportion. And then we divide that by our sample size. Then we close the parentheses and raise all that with the shift 6.5 to take the square root of all of that. And that gives us a standard error of the proportion. We'll just take it down to 4 decimals. And you might need a moment or two to get that typed in properly, so feel free to pause. Of course, if you've done it right, which is half the battle, you can check and see that your number matches mine or is pretty close. Now we need to calculate a critical z-value. Critical z-value will be how far away our sample proportion has to be from our assumed population proportion of 0.5 above to make this a statistically different value. And in this case, we're going to use a function, and we'll look at it under statistical, and it's the norm inverse. But not just any norm inverse, a standardized norm inverse. Where we need a probability, which will be our alpha level. Again, like we saw, it's our alpha level divided by 2. And then you see that it's a negative number. So we can do that, just change that to a negative in front of the norm inverse. And that gives us our positive value look. You see it's almost exactly 1.96 from the point of view that it could be either 1.96 standard deviations higher than the mean or 1.96 standard deviations below the mean. So look at the positive and the negative. Note that the sample proportion is 0.666, and that is higher than our assumed population proportion. So we would be interested in the high value for that. Now we calculate our test statistic z-value, which will determine how many standard deviations away that is. And that formula is pretty much the same as what we had before. Our sample proportion minus our population proportion in parentheses, sorry I went a little quick on that, divided by our standard error of the proportion. And if we drop that down to 3 decimals for consistency, and we'll put that in the next cell to the right. We're good there. So we know that 2.206 is greater than 1.96. So we're likely to reject, but don't forget, we want to make sure that we calculate a z-value. Now, it's not that crazy, or not that necessary, I should say. It is a little crazy for you to calculate the z-value because the software will provide it for you. So whatever makes it easier for you to figure out. Now to do this, we're going to say equals 1 minus, actually we'll start it out with just the formula. So I'm going to insert a new formula, formula insert function, and that is going to be the norm S distribution. Let's find that norm S distribution for the z-value we found above at 2.28, and we want to put in for 1 for cumulative. Now, that's actually the area to the left of this z statistic. We want the area to the right, so I'll put a 1 minus in front of that. And that's just to get the small tail to the right of 2.28. Of course, that's too many decimals. So let's see if we can at least get it down to 4. We use our format painter, grab the standard error, much better. Don't need quite so many. Get that screen back on track. All right, so I've calculated the tail area. We still have to multiply like we did in the sample, in the hypothesis test for means, by the number of sides. Of course, the number of sides is 2 because the hypothesis test H1, the alternative hypothesis, has a not equal sign, which means that we are interested in both sides. So we have to account for both sides. And this then creates the p-value. Again, we could probably format that to be the same. And there we have it. So now, what does this mean? We would reject HO because the test Z value of 2.208 is greater than 1.96, and the p-value of 0.0272 is less than alpha of 0.05. There is evidence that the population proportion of houses with fireplaces is different from 0.50 or 50%. And we go on further to say that because the sample proportion is greater than the population proportion, we're pretty confident that it is greater than 50%. One more to go in this series, and I'll see you in the next video.